There are a lot of kinds of distance problems that we work. One of the more interesting kind is where you have a plane or a boat of some kind that normally goes this many miles per hour, but now the plane meets a wind which is either blowing straight toward it or straight behind it, or perhaps the boat is in a river with a current, so that if you turned the motor off on the boat, it would start to drift backwards. So it would have to go however fast the current is going just to stay in one place. Or perhaps if it were headed downstream anyway, it would be moving downstream without even the motor going. So if we look at this kind of situation, if we have a plane which normally flies 450 miles per hour in still air, but the plane meets a 50-mile-an-hour headwind. Now, a headwind is blowing toward it, coming in at its head. How long will it take the plane to fly 1,200 miles? If it's blowing into the tail, that would be considered a tailwind. If it's blowing into its face, basically, that's considered a headwind when it's blowing toward it. So a headwind is going to slow it down. A tailwind that's blowing in the same direction it's going is going to speed it up. So the distance that we want to look at is 1,200 miles. The rate at which the plane flies is normally 450. In this case, it has to fly 50 miles an hour just to essentially stay in one place, to cover the air that's coming toward it. So its rate, according to someone on the ground, is going to be 450 minus 50, and the time is what we're looking for. Distance is equal to rate times time. However fast you're going times however long you do that determines the distance that you go. So in order to figure out how long it's going to take it to go 1,200 miles, the rate is going to be 450 minus 50 times time. So that's 400t divided by 400. So the time is t is 3, and because we're talking about miles per hour, that's going to be, it takes 3 hours. So that's only one of many kinds of distance problems that we can work with, but that is one of the more interesting ones.